Okay, just in looking back at the last video, I feel like we rushed through this question. That is not the purpose of this study guide. And we want to talk about why there's usually more cloud cover at higher altitudes. Now, in order to do that, we kind of have to start thinking a little bit about the water cycle. Now, we know that the water cycle is powered by the sun. The sun sends down its rays. And we all know that when the sun is out, it gets pretty toasty outside. Now, once that happens, any water that's down below is going to start heating up. Now, as water heats up, as we learned back when we were doing solids, liquids, and gases, and we talked about states of matter, water goes from the liquid form, and when it gets really hot, it turns into water vapor. Now, water vapor is very important to know because water vapor is when the liquid portion of the water gets extremely hot, it changes its state. It's still water, but it changes its state into a gas. Now, this gas rises, and it keeps going up into the atmosphere. Now, one thing that we need to know about the atmosphere that we remember back when we studied the layers of the atmosphere is for a little while in our atmosphere, the higher we go, the colder it gets. Many of us have experienced that when we've gone from, let's say, Boone all the way up to the top of Beach Mountain, and you're like, whoa, it was 60 degrees in Boone, and it's like 40 up here. You do have a massive change in temperature the higher you go up in the atmosphere. Now, we need to think way back to what happens in the changes in our states of matter. And we had the solids, liquids, and gases. Well, you have gained heat in order to turn into water vapor. What happens as it gets higher, it's going to hit this area where it's going to cool off. And when water vapor cools off, it turns from water vapor back into little water droplets. Now, these water droplets attach to particles of dust, and they form clouds. And that is why there's usually more cloud cover at higher altitudes. On mornings when you see fog lying low to the ground, typically what you have happening is there's been some evaporation going on, and that water vapor doesn't get very high before it hits a cool pocket, and it turns into little droplets of water, and you'll see fog form very low at the ground. But that is why there's usually more cloud cover at higher altitudes, because as you go higher in the atmosphere, you're going to start cooling off. Again, we're breaking these things down using the notes that we took on our brain dump. Which observation describes a change in climate rather than a change in weather? And we said we know that weather. Notice I'm not even reading the answers yet. I'm not worried about those. Weather and climate. Weather is your day-to-day things. Maybe you get a weekly forecast for the weather. I looked at the weather this morning and said, sure, I can wear long sleeves and shorts. I'll probably be comfortable at school. Looking at the weather forecast for Sunday, I'm not so sure about that. And we'll find out what happens with that forecast on Sunday. Climate, however, is over a long period of time. Over a long period of time. In class, we said it's very possible for me to look at the climate of Florida and say, typically it's fairly warm there. But there have been days there when the weather was cool. But the climate, when you look at it over a long period of time, you would probably say it's more of a warmer climate. Now, let's look at this. Which is a change in climate, so I'm looking long periods of time, rather than change in weather. The thunderstorm dropped 3 centimeters of rain today. Today, look at this. Today. This is weather, and that is not what I'm looking for. The average summer temperatures have increased over the last 10 years. 10 years. That is definitely over a long period of time. I'm going to say this is climate for sure, but I'm going to make sure that that's my best answer by looking at the others. The snowfall in this area was more this week than last week. Now that is over a few days, but I would not consider that over a long period of time. That is definitely weather. Don't like that one. Feeling pretty confident about my B answer now, but let's see. The average wind speed in April was less than it was in March. Now, that's a month-to-month thing. Now, which of those is a longer period of time? It's definitely this. This is closer to weather. You're talking month-to-month in comparison. But this over the last 10 years is definitely a longer period of time and easily makes me know that that is climate over weather. All right, which best describes the effect of heavy cloud cover on temperatures at night? If you go back and listen to the last video, I think that you'll know the answer to this. Let's take a look at cloud cover. We'll do during the day. And then we'll come over here and pardon my terrible moon, but we'll do it at night. The floating banana. I don't know which one of those that is, but we'll call that a moon, all right? Just bear with me, all right? So here we go. During the daytime, when the sun's rays are coming down, if you happen to have not yellow clouds, if that's the case, we need to worry about something. If you're having cloud cover during the day, the sun's rays, notice they're having a really tough time. They're having a tough time getting through these clouds. So what happens is they bounce off the cloud and go back up. And we all know that typically during the day, cloud cover during the day, if we see that, you typically have cooler temps than if the sun is just blaring down on you. That's any time of the year. If it's a cloudy day in the winter, it's colder than a sunnier day in the winter. If it's a cloudy day in the summer, it's noticeably cooler than a cloudy day. Now let's think about what happens at night. All day long, hopefully, the sun's been heating up the earth, and some of that heat that the sun had sent down has come down and heated up the ground. Well, at nighttime, what happens is the ground releases some of that heat back up. If you don't believe me about this, step on the beach during the day with your feet and tell me if the sand is hot. Is it holding in the heat? Then go to that same very spot at night and step on that sand and tell me if it's still hot or has it released some of that heat. Now let's think about this. It's nighttime. What happens to this heat as it comes up is it doesn't go through the cloud. It's trapped. And it's going to hold that heat in, keeping it warmer at night because it's trapping that heat. And if you listen to the weather, you'll hear them talk about that very often. So let's look at my answers. Realize, again, I haven't even looked at the answers. I drew what I knew first. Temperatures will be cooler than expected. Well, that is not what Mr. Bullen said. That would be, this should be daytime. I am looking for nighttime. That is not my answers. Temperatures will be warmer than expected. I like that one. I'm going to come back to that one. That one sounds like a great answer. Temperatures will change frequently throughout the night. Now, honestly and truthfully, unless we have weather systems moving in, our temperatures aren't changing frequently. throughout the night. Temperature will be no change in temperature through the night. Pull out your mom and dad's phone, for most of you, your phone. Look at the weather forecast right now, and I guarantee you, you will notice that it does not stay the same throughout the entire night. Give me 1 second. Okay, I'm back. So you can even just see, now all this is like this morning, because I can't pull up the night, but you'll notice that does the temperature stay the same? And look at this, like the temperature is changing all the time. We can even guess we can get to tonight's sweet 65, 62, 61, 60, 58, 56, 55. Now that's not a drastic change, but we definitely know that it is not, there is definitely a change. No change is not the correct answer. And we were correct. This is our best answer. What type of weather is usually associated with a cumulus cloud? We wrote this down. This does not say nimbus, which is this one, so no. Foggy is stratus. No. Now, we haven't talked about humid weather yet, so you know that's not the answer. And if you remember from what you learned in class, we definitely said this would be a fair weather cloud. Which instrument is used to determine air pressure? I'm not even really looking at this. I'm going to come back to this, but here we go. Thermometer is temperature. Psychrometer, did we study that? Then that's not the answer. Anemometer is wind, speed. Barometer is air pressure. Go back into my question. What am I looking for? There is your answer. Very easy to eliminate those. What is the main source of energy that causes water to evaporate? Main source of energy, water to evaporate from the surface of the earth. All right, boys and girls, if this is on the test, this is a give me question. You know that lightning is not the answer. You know that gravity is not the answer. And you certainly know that wind is not the best answer. The main source of energy, we've said this since day one, is the sun. No one should miss that question. Water cycle time. You have to kind of know what's going on in the water cycle. You need to be able to kind of label some of these things. Obviously, you don't want to call this rain anymore. This is precipitation, because it could be rain, sleet, snow, or hail. This up here, we all know that condensation is cloud formation. Like the way that rhymes. Okay? If you'll notice, this is running off into, so this is runoff. And now we have something, somehow water is going up into the sky. Feel like I just talked about that. That is evaporation. Now let's read my question. In which part of the water cycle does water change from a liquid to a gas? I had evaporation right here. That is here. And that is how you would answer that question. Final question from our packet. I've got 1 minute and 20 seconds to do this. Let's see if I can get it done. What must occur before clouds can form? All right, I'm going to kind of go through the process that I went through a minute ago. Okay, so let's see. The sun heats the water. Water evaporates. The vapor rises. Vapor cools. And condenses. And again, condensation.
Oh, you're in the dark. Hey.
Is cloud formation. Yes, Miss Levy, I'm in the dark and you're on the video. All right. Water vapor must get warmer. Is that what I said? No, it is not. Water vapor loses heat energy. Now, I did not call it that. I said that is cooling. I'm liking this answer. Precipitation must begin to fall and run off. Now, that is when clouds kind of go away. Transpiration must add water vapor to the atmosphere. Now, there are two decent